Okay, for MYP1, this is just a quick review of the algebra notes in case you happen to miss anything in class. So I started off with a quick definition. What is algebra? So I defined it as a logical process of finding unknown quantities by substituting letters for numbers and manipulating equations. So if you didn't manage to get that down in class, now's your chance to pause the video and get that jotted down. So chapter 1 was just that sentence, and then I talked about balancing equations, and in class we represented the equation 3x plus 2 equals 17 with jelly beans. So we had somebody standing up the front with 3 mystery bags of X jelly beans. We don't know how many jelly beans X is yet, but we do know that they're all the same. And then 2 loose jelly beans, so that's 3x plus 2. And then in the other hand we had 17 loose jelly beans, and the 17 loose jelly beans represents the number 17. So that equation 3x plus 2 equals 17 was represented by somebody standing there with 3 unknown bags of jelly beans plus 2, and then equals in the middle, and then 17 on the other side. So the idea of that is to introduce the whole concept of balance in equations. We always like to balance equations, and as long as you do both sides, or as long as you do the same thing to both sides of this balance, then you maintain the balance. So that was that. And then if we took 2 jelly beans from each side, the balance was maintained. So I can just kind of click on that in my PowerPoint that I made it in. I can take 2 away from that side and 2 away from that side, so that there's 3 bags on one side and 15 jelly beans on the other side. And then if 3 bags is 15, you can divide everything by 3 and say 1 bag must be 5. So if we take 2 jelly beans from each side, the balance is maintained. The concept of balance is fundamental to algebra. Whatever you do to one side of an equation, you must do exactly the same to the other side in order to maintain the balance. And if you're in my class, you'll hear me say that that sentence in blue many times over a period of 5 years. Okay, so moving on to the next little bit. And this is how I like to set that whole situation out as equations. So 3x plus 2 equals 17 is what we started with. I took away 2 from both sides, so it was 2 jelly beans, but the number 2 in the equation. So when I took away 2, this 2 disappeared, and then the 17 went down to 15. So the idea of that is to simplify the whole system by getting the bit with x on its own. So we just have something with x equal to a number. So 3x is equal to 15. I don't want to know what 3x's are. I just want to know what 1x is on its own. So I divide everything by 3, both sides. And then when you divide by 3, both sides, you get x equals 5. So I like to set this out in this way with little notes on the side and keeping everything lined up. So see how the equal signs line up, see how the x's line up, see how where there used to be a 2, there's now a space, and you can see where everything has come from, and from each step to the next, what the logical progression is, and it's easy to follow if you keep things vertically lined up like this. Now I have seen quite often people do this thing where starting from 3x plus 2 equals 17, then they make the next stage 3x plus 2 minus 2. Oh, that's not a minus. I can't find the minus on my keyboard. 3x plus 2. I'll find it in a minute. There it is. 3x plus 2 minus 2 equals 17 minus 2. So instead of having a little note on the side that says minus 2 both sides, they kind of write it in the main equation. I'm not a big fan of that as a rule. I think it's just a little bit on the confusing side, and I find it personally much easier to have these little notes on the side saying that I'm doing this both sides than to have it all messed up in the workings here. One extra little thing here, 3x means 3 times x when you see a number next to a letter in algebra. So 3x doesn't mean 30 something. That's quite a common misconception. You'd be surprised. Okay, example 2, we did 8x plus 6 equals 18. So I took away 6 from both sides to get the bit with x on its own. So 8x equals 12. But then I don't want to know what 8x's are. I want to know what 1x is on its own. So I divided everything by 8, both sides. And then when I did that, I got a single x equal to 1.5. Example 3. 5x plus 8 equals 15. So I subtracted 8 both sides to get the bit with x on its own. So I got 5x equal to 7. But I don't want to know what 5x's are. I want to know what 1x is on its own. So I divided everything by 5 both sides, and that gave me x equal to 1.4. Example 4, you've got a sneak preview of the first step there, but try and do this one on your own. Pause the video before continuing with it. Okay, so hopefully you've done that. 6x minus 4 equals 68. This time I need to get rid of the minus 4, so I have to add 4 to make the minus 4 disappear, and then it's gone. So I've done a little cartoon gone there. I wouldn't do that normally, but I'm emphasizing the point. Okay, so adding 4, the minus 4 disappears, and you just get 6x equals, well, that's got to be 72 because you're adding 4 to both sides. And then I don't want to know what 6x's are. I want to know what 1x is on its own, so I divide everything by 6, both sides, to get a single x equal to 12. Okay, moving on now to the next example. 5x minus 2 equals 53. Just try and do that one on your own and pause the video. Okay, so hopefully you've done that. 5x minus 2 equals 53. I want to get the x bit on its own, so I need to get rid of the minus 2. So I have to add 2. So adding 2 to both sides, I get 5x, and then the minus 2 disappears, equal to not 53, but 55. 5x equals 55, and then I don't want to know what 5x's are. I want to know what 1x is on its own. So I divide everything by 5 to get a single x equal to 11. Yet another example. So we've got, oh, now this is going to be a little bit trickier. X over 2 plus 11 equals 18. So x over 2 means x divided by 2. Just try and do that one on your own before looking at the answer. So pause the video again. Okay, so I hope you've done that. Let's have a look at it. So again, I want to take away 11, in this case, to get the x bit on its own. So if I take away 11 from both sides, I get x over 2 is equal to 7. But I don't want to know what x divided by 2 is. I want to know what a whole big fat hairy x is. So I need to multiply everything by 2 this time to get a whole x. So multiplying by 2 both sides, I get a whole x equal to 14. So the final answer is x equals 14. Good thing with algebra, in all of these, you can take your final answer and check it back in the original equation. So 14 divided by 4, that's divided by 2, that's 7. So 7 plus 11 does make 18, so we know that that works. Oh no, not another example. Okay, so this time x over 7 plus 14 equals 22. You've got a little clue there to the first step. Pause the video, try and do that on your own. Okay, so I hope you've done that. So first step is take away 14 from both sides, and that's to get the x bit on its own. So taking away 14 from both sides, x over 7 is equal to 8. But I want to know what a whole x is, so I need to multiply everything by 7 to get a whole x. So multiplying everything by 7, both sides, we get a whole x is equal to 56. Yet another one. So again, try and do that one on your own before continuing the video. Okay, so revealing the answer now. X over 6 minus 4 equals 74. I want to get the x bit on its own, so I need to get rid of the minus 4. So adding 4 to both sides, I get x over 6 is equal to 78. But I don't want to know what x divided by 6 is. I want to know what a whole big fat hairy x is. So multiplying both sides by 6 to get a whole x, that gives me x is equal to, well, 78 times 6 is 468. So final answer, x is 468. And that takes us up to the end of chapter 2 of this little unit.